We will go over all of those things. And we are starting right now. So, welcome to everyone who has joined us for the day. We are TC. I am TC Homework Help. Um, TC Homework Help 180. Um, we are still live on Instagram. My apologies for that interruption. We are back. So, let's just start with a funny story. Let's start with a funny story. So that hopefully you will never forget the number of cards in a deck. So back in the day, and I can say back in the day because I'm 40, and when I was about 10, back in the day, there was this game called 52 card pickup, right? So when you played 52 card pickup, it wasn't necessarily fun. So what would happen is someone would come up to you and say, "Hey, you want to play 52 card pickup?" And my little 10-year-old self said, "Yeah, I want to play 52 card pickup. Um, what's that?" And what they would do is they would take, now this is not the full deck, this is just one of the suits. We've talked about the suits before now. This is just one of the suits. This is the whole family of the spades. And so I'm just going to demonstrate with that. But what they would do is just take the deck and they would do that number. They would do this number and all the cards would fall over the place and they would say, "Pick it up." So that is 52 cards pickups. And if you could imagine my little 10-year-old face as I am looking at this person who is so serious about you picking up the 52 cards. And I never forgot from that day moving forward that there are 52 cards in a deck. And that is going to be the necessary information for us to complete this lesson today. And we're going to be brief, but not too fast. So again, today we are doing probability. We're looking at what are the odds, part 3. Full deck, no jokers. So the jokers are here because when you pull out all of the cards in the box, there are 54, but that is not what we're working with. When any assessment, any test, your denominator should be 52. So hopefully after that story, you can think about my face as I was picking up those cards and laugh and remember that, oh yeah, I picked up all 52 because the person who asked me to play, and I agreed, was expecting that I picked those cards up. Picked it. That's such bad English. I'm getting it together. Welcome back. Welcome back. All right, so let's look at the warm-up. We've been talking about probability for the last couple of weeks. So the probability of the first one, we know we've been working with a number cube, so hopefully we recall that there are 6 sides to a number cube. So the probability of a 2, we would consider how many 2s are there on a number cube? Well, we just so happen to not get we have 1. So there's 1, 2, on a number cube out of the possible 6 sides, which makes the probability of 2 1/6. And now let's look at number 2, just another refresher because we have not actually talked about flipping a coin, but we have talked about probability several times. So same thing, part over whole, part over whole. What are the part that we're looking for? What is the total number of options that are possible? Well, there is one head on a coin and there are 2 sides of a coin. So the probability of flipping a head if you were tossing a coin is 1/2. All right, so let's get into the lesson. And as we reviewed, there was a little bit of homework, so we can just go through that really quickly. So last week we discussed the 4 suits, and last week we looked at probability of a set of cards, and I took a random set from the full deck. Today we're working with the full deck when we're looking at probability, but that's not exactly what we did last week. So we do want to review some things. So I've pulled out the whole deck again because not every person has ever played with a deck. Just to go quickly to show all of the cards in each suit. Now I'm not going to do each suit. We see here that there are 1, 2, 3, 4 suits. And so I'm not going to do each suit because that's not necessary at this time for me to do that. But what I am going to do is I'm going to count for you 1 full suit. And so you begin with the ace. That's kind of your 1. Now, ace is the highest card when you're playing spades, and that's another conversation for another day. But that is the 1 of the suit. And then there's 2, 3. Oh, I'm out of order. I was playing. Sorry. 4, 5, 6, 7, 8, 9, 10. After the 10, the jack, the queen, who is stronger than the jack, and then the king, who is stronger than the queen. So with respect to how many cards are there in each suit, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So for future reference, for any assessment, there are 13. We began with 13 out of a total of 52 because we've discussed that earlier today. Now, because all of the suits are the same, as far as the same number of cards in each suit, then there we go. My apologies. Then we want to go to the probability of a heart. So the probability of the heart would be equivalent to the probability of a spade. There are 13 hearts in the deck out of a total of 52 cards. The probability of a club. There are 13 clubs out of a total of 52 cards. And the probability of a diamond is 13 out of 52. So yes, in our deck, we have a total of 52 cards. Each suit is represented by 13 different cards. And those are the numbers that we're going to be working with. All right, we are back. All right, so let's move on. We have reviewed, we've warmed up. I'm adjusting my camera. And let's move on to with and without replacement. So at this point, I'm going to take the full deck. And I'm just going to shuffle in the spades. I'm shuffling the spades because I want to pull some random cards for our examples. That was a terrible shuffle. It really was. What is our time looking like? We've got about 10 minutes so far. Hey, Facebook again. Thank you for joining me if you're on here. If you're not, you can always view us on YouTube. And I really appreciate your time. Just trying to get an idea of the type of instruction that will be on this channel. That's what this is about, getting it out there, getting the word out there. All right, so let's look at the probability of, I had an agenda. So now we want to talk about with and without replacement. That's what we're talking about today. So we want to talk about probability with replacement, meaning we put the card back. Put the card, the item back. So let's jump into that for a second. So let's say probability, we're going to pull a card. I'm going to pull a card randomly. So if I pull a card randomly out of the deck, I get probability of 2 of clubs. The probability of 2 of clubs. I pull the 2 of clubs, and we want to know the probability of a 2 of clubs. Well, how many 2s are in the deck? We know that each set has 13 cards. We know that each suit has a deuce, a 2. So that means how many deuces or how many 2s are in the entire deck? Well, there are 4. 1 for each suit, and that is 4 out of how many cards? A total of 52, and that's why we began with the denominator. Now, if I put this card back, boom, the question would be, what would be the probability of pulling that card? Well, at the end of the day, so with replacement, I put the card back, so it's now still a part of the set. If I were to try to find the probability of a 2 of club, again, the theoretical probability would be the same because there are still 4 2s. Well, I made a mistake. I'm sorry. This one should have been just a probability of a 2. The probability of a 2. Now, the probability of a 2 of club is there's only 1 club. I made a mistake. I apologize, and I'm going to correct that. There's only 1 club out of the 52 cards. And the probability of a 2. So the probability of a 2 is still 4 of 52. So let me go back and clarify and clean all that up. I apologize. I made a mistake and I want to correct that right now in real time. So what I should have asked in my first question was simply a probability of the 2, not a 2 of club. The probability of a 2 is a 4 over 52 because there are 4 2s in the entire deck. Now, if I was looking for the probability of a 2 of clubs specifically, which is not what I wanted, but that's what I said, then that would be 1 out of 52 because there is only 1 2 of club in the deck. Now, if I'm looking, that was just that correction because I made a mistake before. So 4 out of 52 being the probability of 2. Now, if I put that back, so I replace it in the deck, and I look again for the probability of 2, that is going to be the same. There are still 4 2s in the deck of 52 cards. My apologies. Let's do another example since I made a mistake. Let's look at the probability. We're going to pull a random card, and I'm not going to pay attention to suit in this moment. We need another replacement. So let's look at a jack. So the probability of a jack equals how many jacks are there in the deck? Well, there are 4, 1 for each suit, and the probability is 52. So if I put that back, so I put the jack back in the deck, I don't know where it is, and I'm asking what the probability would be. It would be the same as it was before because nothing has changed. There are still 4 jacks, there are still 52 cards, and this is what I'm looking for. Now, let's say we looked at the probability of a jack. We pulled a jack, but we did not replace it. So this is without replacement. What happens? Well, if I took out the jack, boom. This is not the jack, but let's say that were. I took out the jack. What happens is one of the jacks is now out of the deck. So how many are there remaining? Where there are 3 jacks remaining in the deck, and there are only 51 cards in the deck because I took a card out of the deck. So replacement will change your denominator, and it may change your numerator. Let's do another one. How many minutes are we? About 15. Let's do another one because my first example was not that clear. So we're going to go a couple of places. Let's pull a random card. We are going to go without replacement first so we can look at it. So let's look at randomly. We've got a 7 of diamond. Okay, so we pull a 7 of diamond. So what is the probability of a 7? So how many 7s are there in a deck? Well, there are 4 7s in a deck. And what is the probability? How many cards are there in a deck? There are 52 cards in the deck. So the probability of pulling a 7 is 4 out of 52. Now, let's say we do not replace this card. So I'm not putting it back. It's going to stay right there. What is the probability of a 7 now? Well, at this point, I have to think about, I've taken a 7 out. How many more 7s are there in the deck? Well, there are 3 7 remaining. There's the 7 of spade. There's the 7 of heart. There's the 7 of club. There's 3 7s remaining. So if there are 3 7s remaining, and how many cards are remaining? I took one out. We know we had 52 cards in the deck. We now have 51 cards in the deck. And that would be the probability of a 7 without replacing the original 7. Now let's look at, we still put that 7. Let's look at the probability of a 4. Let's look at the probability of a 4 without replacing the 7. So, okay, we didn't replace the 7. How many 4s are there in the deck? Well, we haven't taken any 4s out. So there are still 4 4s in the deck. And we know that there are 52 cards in a deck. We do. However, we took one out. So at this point, our denominator is 51 and not 52. So in this moment, although I took that card out, it did not change the numerator, but it did change the denominator because we don't have 52 cards. Even though we started with 52 cards, when we took out that 7, it still impacted the denominator because I have one less card in my hand to pull from, which changes the probability of that value. Beautiful.